Relax. Okay, 这fever is very uncomfortable. Okay, now I'm wearing mask. Also, I really feel a bit difficult to talk. Okay, have you all tried? Perhaps I give you some hints, then I give you some time to do it. Look at question 4. There are three short circuits occurred at three-phase short circuit occurred at point F here. So assume that the prefault current at 0 and the generator operated at rated voltage determine the fault current. So in these questions, they just tell you that it's at the rated voltage. It means 11 kV and 33 kV because this is 1.3. So 11 cell to 33 kV. So means supposedly the voltage should be the same. Then you need to change it. This question is about the can I say so? Actually, you have two ways to do it. You want to do using the last time that you learned the per unit also can. Okay, you want to use the new method percentage also can. Okay, so here the 0. Yeah. 15%, 10%, you can put it as 0.15 and 1. Okay, that's my answer. So you can make 0.15. So you can make it here. Then you can make it. This one you can make 0.15. This one you can make 0.1. Then 0.05. Are you okay? Then I understand that they didn't tell you the base for the power, right? So actually you can set, if not a question like this, that means you can set anything to be the baseline voltage. So they set the 30 MVA. Okay, they set 30 MVA as the base. Okay, so can you do it now? But of course, in the exam, right? Then I will fix it. Fix the base value. So this one they set 30 MVA as a base. So you use a formula to change it to get xg1, xg2, x transformer, then x line or z line. Okay, can you do it now? So what is the formula that you need to use? You can use a PU formula. The x PU new equals to xo PUO, and not VO over V new power 2, because the V value now is the same, so this one actually no need. Then S new over SO here. Yeah, basically you need to change S new and SO. We set new S new as 30 MVA. Okay. S new as 30 MVA. So this is a new base. Then means voltage is the same. Then new O1 will be 20 MVA, 10 MVA. This one 30 MVA means the same. And this one you need to use what? S Z equals to what? V squared over S base. Okay. V squared will be 33 kV. S will be 30 MVA. Okay. Then you get the base value. Then the Z line will be actual 3 plus 15J actual divided by base of Z base. Okay, I give you 5 minutes. Please do it now, and later on I will ask answer for each of the subcomponent G1, G2, T transformer. Okay? Please do it now. Okay, can you do it? Can I call your name for answer? Let's look at, so what is the value for xg1? John, you are very fast. Okay, 0.225 pu. Yes. Before I call name, John already help you to answer off. Very good. Yeah, space here. So xg1 equals to 0.225 jpu. Okay, anyone can get it? Then what's your xg2? Yes, then why good? 0.3 jpu. Then x transformer. Anyone? X transformer? Wing, can you get transformer? Transformer, yes. 0 point. Supposedly, transformer is original value, yeah? Because it has the same base for voltage and power. And Z line. Yeah, Z line. Yingxuan, can you get it? Wei San, can you get it? Kiwoon? What's your Z line value? Anyone? Can you get it? So you need to use this V squared over S, which is V is 33K. Okay. Our 2S will be 30 amps that we set here. Okay. Then Z line will be 3 plus 15J divided by this Z base value. You put it here, then you should get what? Z line 0.0826 plus J 0.4132 pu. Are you okay? Listen? Okay. Kim Woon, Cậu Yên, Minh Hằng, Song Chiến, Hello, Ying Xuan, Zuyun, Nicholas should be fine, right? Okay. Okay. Can do. If you can do this, then it's not a problem at all, right? Then basically you can redraw the circles in diagram form, which is something like this. Okay. So your plot is here. Plot is here. So this will be your xg1, xg2, okay, then x transformer, and this will be the Z line. Okay. Then if you want to find the fault here, right, they ask you to find the fault current, right? So I fault will be equals to voltage V fault divided by Z total. So Z total will be this one. So it will be parallel series. Okay, then what is your VF value? They tell you pre-fault. Generators are operated at the rated voltage. So that means VF will be equals to 1 pu. Then Z total will be parallel xg1 and xg2 value parallel it, then plus with transformer and plus with Z line. which is 0.5975 angle 82 degree. Then you settle here, then you are going to get 1.674 angle negative 82. Yeah. Yeah. Okay. Negative 82 degree. This one will be in, okay, this one will be in PU. Okay. Then if you want to get IF in PU, you want to get IF in actual, then you need to find I base. I base will be equals to S over 3V. 3V. So it's actually equals to 524.8 M. Then IF in actual will be IF in PU multiplied with I base. So this value, PU value multiplied with the base value, then basically you get 878.6 angle negative 82 degree. You okay? This is considered the easier way. If you're okay, any question? This one PU value, okay, right? IF PU, just the Ohm's law. Then find the base, and then your actual value will be the PU times with the base, okay? If you're okay, then we go to question 6. Okay, have you tried question 6? Can you try to look at it? Okay, can you do it? Question 6. Okay, question 6 is a little bit spatial. Okay, estimate the short circuit MVA at the bus bar of generating station A. 1 minute, let me close my door. My son is very happy watching his favorite Ultraman cartoon. The later will be very noisy. Okay, let's look at this. So you have the generating station A is 1005 MVA, another station B is 1002 MVA. Okay. Okay, the generating station is at each station is 33 kV. Okay, if these stations are interconnected through a line of reactance of 1 ohm and negligible resistance, calculate the possible short circuit MVA at both stations, means F1 and F2. So you want to calculate F1 and then F2. Okay. So actually this question is a little bit the info not enough. So you need to let base MVA, okay, the 1000. Okay. So this base MVA 1000 should be given in the questions. Okay. Should be given in the question. Let base MVA be 1000. Sorry. Not 100. 100. 100. 100. Okay. Let base MVA be 100. So your percent XA is actually equals to base MVA divided by short circuit MVA times 100. Okay, this is a formula. So your base MVA given 100, this 100 given, right? Then short circuit MVA will be given here 1005. Okay. Then times 100. So it's actually equals to 6.67%. So this one actually, this one supposing I should remove, Okay. This is a diagram of answer actually. Suppose this one I should remove. Okay. Then you should get 6.67, which is here. Then only I write back 6. Then only I write back 6.67 here. Then how can we get 8.33? So same thing. So you have percent XP is equals to 100 divided by 1200 times 100. So you have 8.33%. Which is here. Any question? Hello, are you all there? Already go for tea break, is it? Can you get this? 6.67 and 8.3. So this one is supposing it's not given, Supposingly it's not given in the diagram. Okay? Suppose you need to do it out yourself. So you get 6.67, then you put inside here, and you get 8.33, you put inside here. Okay? Are you okay? Then Hey, can I know whether any of you still around? Or actually you all can't hear me? Hello?
I guess maybe you should scroll down in the chat box.
I should what?
Scroll down.
Slow down?
We're typing messages already, actually.
Oh, okay. The timing, yeah, well, supposedly it will show, just now it didn't show. Okay, okay. Yeah, now I can see now. Okay, Nicholas asked, does Z total include resistance? Oh, Nicholas, your question is, I didn't really get I didn't really get the message just now, no? Now I receive the message. Okay, so Nicholas mentioned about here, okay, does Z total include resistance? Nicholas, your question is about which one? This one? Question 4, ah? Okay, then if you say you use what? And it should be okay one. But then it include the resistance, you need to use another way. To include the resistance, you cannot just add them together. You need to, for the percentage way, you need to use what? R squared plus x squared, then square root it to get the z. Okay. I think last time students try the percentage way and then told me they can get answer, so that's why I didn't really look into it. Okay, but no worry. For the symmetrical form, all will be this kind of questions. Without resistance, 59.7. 59. Eh? Oh, my answer supposed is include resistance. You sure? My PU method supposing I include resistance. Yeah, include resistance, so I get 0.5975. How come it's different? How come you get 59.75 if you are not including the resistance? Like that. Because you are putting J, right? How come? Yours is plus 41.32. From here you get 59. One minute. I suspect this because suppose I get 54. Okay. Yeah. I think you should get 54.18 instead of 59.75, yeah. Okay, because it's impossible. Why I say so? Because I add in the resistance, I add in this resistance value, then only I get this one. How come you didn't add? Then you can get the same answer as mine. Okay, but I believe you'll be able to get the same answer. Okay, then we get back to this question. This one, are you okay? Are you okay? So apply the formula, then you get the percentage. Right? As I say, this percentage actually is not given initially. Yeah, is actually they only give you something like this 1,002 MVA and 1,005 MVA, and then the base MVA is 100. So this is how they get the answer. Okay, then generator A, B set already. What you have another info that you need is a resistance value. So it's a bit tough to breathe in the mask. Okay. Where are we? Reactance of interconnected. So reactance percent x 1 ohm, this 1 ohm value, then component. Then you need to use a formula kVA multiply with the x value over this, because this is in actual, so you need to change it to percent. This is a formula kV power 2. So formula given is kVA. Now they say 100 MVA, so you need to substitute 100 MVA, right? So 100 K 100 K here. Then x will be 1 ohm divided by 10 kV 33 kV. Okay, so 33 over 2. Can you get it? So you need to look at MVA and kVA carefully. Yeah, you cannot substitute 100 in, because this 100 is 100 MVA. So if you from MVA you change to kVA, so it will be 100K. So this 33 kV, so you no need to substitute 33K, you just put in 33. So from here, percent x for the 1 ohm to be 9.18%. So this one is 9.18%. 10 is, yes, 10 is constant here. Yes, 10 is constant. The formula is in the section note there. 10 is constant. Okay. Okay, then you already have all the percentage for all the components, 1, 2, 3 components only. Then you can start to do. So if you're at F1, it means it will be at this point. If it is at this point, it means what? Series here, right? Then parallel with this side. So you have 8.33 plus with 9.18. Okay. Then parallel with 6.67. Understand? At F1, the total x will be 8.33% plus with 9.18%. Then parallel with the generator 1, 6.67%. Yeah, it's 9 series, right? Then you parallel here if you're at F1 here. Okay. Then from here you will get 4.83, I think. Okay. Then you can, once you have the percentage total x, then you can find the short circuit MVA. Short circuit MVA equals to base MVA times 100 over percent x total. This is maybe the percent x total. So a base MVA is 100 multiplied with 100 and divided by 4.83%. So then you get the answer, which is 2070. This is your answer. Okay. Can you get it? So here, series, then parallel this one. Okay, so why you may feel weird why I can combine all the x together? Why this is in 1 ohm? But then you read the questions line reactance of 1 ohm. So the reactance, this is reactance, not resistance. Negligible resistance, no resistance. So if it is a resistance, then different story. You need to all the x you need to plus together. Then r you need to plus together. Then you need to find percent so-called the z then equals to x squared plus r squared. Then square root. Understand? So you can't just straight away plus together here. But then this okay because given is reactance. Yeah, reactance. So this is x value. Yeah, Nicholas asked. .66 is not at the base on. No, 6.67 is the base of 100. Okay, so it's actually like this value initially you don't have this value and this value. Okay, this is a diagram of explanation the answer diagram. So initially you only have this info. Okay, then so you actually don't know what is the percent x for a and b, but then they tell you that it is 100 1050 MVA and 1002 MVA. So from this value, then you can note when you set the base be 100, then you can find the percent x be 6.67 and percent xb be 8.33%. Nicholas, can you understand what I mean? Others, are you okay? Okay. You all type anything? I believe it is in the notes. I believe it is in the notes. Need to find the short circuit MBA when 4.2. Yes. Next will be the 4.2. So at 4.2, some stories there that you actually now is at this point. So the same thing, same steps. So now you have to add here 6.67 plus here 9.18. Then you pair with 8.33. That's that. So at 4.2, at F2, then the total percent x total will be equals to 6.67% plus with 9.18%, then parallel with the other side 8.33%. Understand? So you have this side now, then parallel with this 6.6. Sorry, F2 here. So this one series, this one series, then now parallel with F2 8.33. Okay? Are you okay? Then the same formula, this formula, short circuit MVA will be equals to 100 times with 100 divided by this one. You get what you get 5.46%. 5.46. Then you get 1831 MVA. Are you okay? The 20 MVA and 1 ring in question 4, the short circuit MVA. Question 4. This question actually is different. This question, supposing it target for PU, it target for PU question, PU solution, for unit solution. And it can't say that it is the. It can't say that it is the. It should be 15% then it is at 20 MVA and 10% at 10 MVA. Yeah. Short circuit MVA. It is not really short circuit MVA. Okay, it's just the MVA values for G1 and G2. Then if you fix it, if you fix the DMVA as the base, then you need to change 15% and 10%. Still remember, right? There's a formula to change, right? The ratio formula, right? Okay, so means like this one, 5% is the DMVA, then 10% you need to 10% 10 MVA, 10 MVA change to 30 MVA means you need to times 3. So 10 times 3 is 30%. Nicholas, can you get what I mean? But anyhow, this question actually is not target for the percentage solution. This is that question actually target for the PU solution. So if short circuit MVA is actually same as short circuit current. Short circuit current and current is different thing, right? So when during a short circuit conditions, then you have short circuit current as well as short circuit MVA. Understand? SC means short circuit, yeah. Short circuit. Yeah, the formula is short circuit MVA equals to base MVA times with 100 divided by the percent X. And this equation this is actually very easy, right? And base already fixed already, 100 is fixed. Then percent X total is just a total so-called the reactance, total percent impedance or reactance until the fault position. So if the fault here, that means here and here series, then parallel with this side. That's it. Then you substitute in, then you get the answer. Is it in question 7? Oh, then we go to question 7. Okay, question 6, okay, already, right? This one, question 7, 6, I say a bit spatial is because normally we will give you percentage of the component, which is so-called the OPU value. Okay, but then this question is a bit spatial. They give you a MBA and ask you to find out what is their percentage, percent X and percent X B. Okay, so I say this is a bit special. Then MBA. Okay, then we look at question 7. 10 MBA. Yeah, actually it's a bit info not enough. So in base MBA is 10 MBA. Okay, so this 10 MVA is actually the base MVA, 6.6 kilowatt and 3-phase star connected. Okay, star connected. Alternator having a reactance of 20% here. It's connected through the 5. This is a standard question, so 20% we give, 10% we give. Then through a 5 MVA, then 6.6 kV and 33 transformer. Okay, so this is transformer of 10%, transformer of 10% reactance to a transmission line of resistance. So they tell you we have resistance and reactance, and then it is per kilometer. So and then 55 kilometers along the line. So means you need to times it 55. Yeah. A short circuit occurred between the 3-phase contactor. Find the current fed to the fault by the alternator. So the fault location is here. How are you going to do it? So first of all, we need to make all the percentage is standard using 10 MVA. So this 10 MVA 20%, okay lah. So XG 20%, no problem because it follow 10 MVA, right? Then percent XG, percent X transformer. So transformer is what? 5 MVA and 10 MVA. Then 5 MVA is 5 MVA, right? Now you want to change it to 10 MVA, so it will be 10 will be 20%, right? So you use a ratio method, 10 divided by 5, then times with 10, then you get 20%. Okay, what I mean, right? The ratio method, 5 MVA is equal to 10%. So now 10 MVA is equal to how many percent? Okay, so you need to use 10 times 10 divided by 5. So you get 20%. Okay, this one settle, this one settle. Then the transmission line. So percent XR, yeah, XR, or we don't call X, sorry. We straight away use resistance. So percent R for the line will be what? The equation will be like just now, kVA times with resistance in ohm divided by 10 kV power 2. I think same as just now, right? Equation just now, this one. kVA times with X over 10 times kV power 2. Okay, so what is kVA? Now it's 10 MVA, right? So 10 MVA, you need to substitute kVA. So it will be 10 K, right? Times 10 to the power 3, 10K. Resistance will be 10 ohm, right? In ohm, resistance 10 ohm. Okay. Eh? Okay. Then divided by 10 kV, kV will be 33 kV. kV, you don't need to substitute 33. You substitute 33 K, don't need to substitute K. 33 kV. Are you okay? I think there's a mistake here. Resistance and reactance per conductor per kilometer, right? Oh, yeah. Okay. You already multiply with 50. Then multiply with 50. If 50, oh, sorry, yeah, it's 50K. 50 kilometer, not 55. 50 kilometer. So you really substitute, multiply with 50 kilometer. There are a lot of mistakes in this question. I'm so sorry. Okay. 50 kilometer. Are you okay? Then that's why you substitute 10, 10 ohm. Given is 0.2 ohm. Multiply with 50, then you get 10 ohm. Okay, so basically here will be 9.18%. Then percent XL, transmission line. So the same equation, 10 times 10 to the power of 3 times with 50 ohms now over 10 times 33 kV power 2. So you get 45.9%. Yeah, 45.9%. Yeah, the 55 kilometers is wrong. It should be 50 kilometers. Yes, if you have the different base MVA, the final answer will be the same. But no worry, because your final exam will have this. Your exam or test will have the same base value. I fix the base value in order to ease my marking. I think base value given, yes, base value will be given in the exam. In the lecture notes, we have one example. They use different base value and then they show you that they can get the same answer. There's an example in lecture notes that I think I discussed that day before. Are you okay? So next, because you have faults here, right? So you need to add all together, but you can't add all. You cannot add this resistance together. So means you need to have percent X total, percent R total. So R you only have one thing, so it's 1.18%. Here you add up all will be what, 20% plus 20% plus 45.9%. Then you get 85.9%. Okay. Then percent exact impedance will be square root of x power 2 plus percent R total power 2. So which is 45.9 power 2. Not 45, 85.9. 85.9 power 2 plus this one, plus with 9.18 power 2 square root it. Then you should get 86.4%. Are you okay? Then last step already. So you can find short circuit MVA. So by using the formula 10 times 100 divided by 86.4, then you get 11.57 MVA. And then the short circuit current ISC will be equals to 11.57 short circuit MVA times 10 to the power 6 mega divided by square root 3 and 6.6 K. So you get 1012 M. So this is short circuit current. Are you okay? This is answer for this question. So means in order to find ISC, you have to find short circuit current, then you need to use short circuit MVA. You okay? Why is it 6.6K? 6.6K 吗？why the 6.6K? Yeah, not 33K. Wait, I mean. Oh, yeah. Because this is one thing by alternator. So alternator is here. Alternator means generator 6.6K. They want to know the current to the fault by the alternator. So you are using 6.6K. How to know series or parallel? Diagram more. This diagram is series only from generator here. From fault is only a series diagram. Then of course it's series. Question 6, Madam CJ. You look at where is your fault location, because your fault location is here. When your eye need to look inside the fault location. If your eye need look inside here at F2 what happened? So this one and this one is two different lines already, right? Edina. Yes, what Zhenwai say is true. If by transformer, yes, by transformer normally won't be by transformer lah. By transformer is 33K. It will say mention by the transformer high side of high voltage side of the transformer. That means you are using 33 kV. Yeah. Okay. Yes, the fault is connecting to ground. You are true. You are right, Nicholas. The board is connected to ground, yes. So this one is very obvious series. Your eye is here. Okay, then you look inside, it's only one straight line, right? Then this one definitely parallel. Okay. Yes, you are right. If fault here, for example, the fault here is here. You are right, Edin. I may change the question. I may use the same thing, then I change the question. If the fault is here, yes, because your eye need to inside here, right? Then this side and this side, so it's parallel. This side series, this side series, right? Then both of them parallel. You are right. Good question. Like that, all possibility you already ask and discuss. That means, sure, no problem for your test. Now I already too easy already. But I add in some theory questions to pull down the marks. If not, then but then if not online test, then the theory part also you can actually Google. So no problem at all. Nicholas, you don't know about what? This is hard to you. Are you sure? No worry. It's actually very easy. Okay. Yeah, we only have these questions. Perhaps I think I will get maybe 2 more questions and post to Google Classroom. Then you can try to do it and we can discuss again. Since our test is week 11 now, we still have 2 more weeks. Any questions? If no questions, discuss lecture 7, okay? Then I need to, you already watched the recorded video for lecture 7, right? So 7A and 7B. Okay, so I just a quick discussion only. Are you okay? After I brief you about the content in lecture 7, then you can start with tutorial 7, okay? Hard. Yeah, I think because you are not getting used to it, after you do, more questions, then should be fine. Yeah, I also think want to add more questions to that symmetrical forms chapter. Yeah, recently a bit busy. I will do it later, okay? Yeah, maybe during this weekend. Oh yeah, because of FIP can capstone a lot of students, okay? Have a lot of that problems. Then later the COVID cases then I need to do the report here and there. Okay, let's look at this unsymmetrical faults. So unsymmetrical fault is basically, you have 3 phase, right? That means not all the 3 phase shot together. It can be 2 phases shot together or 1 phase shot to ground. So you have different conditions. This is not very important. This is example. So if your fault occurred here, then first of all, what you need to do is you need to draw the positive sequence network out, negative sequence network out, and zero sequence network out. So you need to draw this out. And why here is empty, open circuit here? It is because of delta. So you still remember we learned in the sequence network chapter, right? If it is a delta, that means it is open circuit for zero sequence only, zero sequence. So that's why it's open here. Are you okay? Then, so based on this diagram, this is a PU way, PU way. So you use a PU way to find out the XG, XT1, X line, XT2, X motor. Then you draw the diagram out. Okay, and only the positive sequence it will have a source. Okay, negative sequence no source, and only the zero sequence that is open at circuit at the delta place location. Okay, so after you have a positive, negative, and zero sequence, then can you find the fault Thevenin impedance? So if fault happened at here, it means at here. It means it is at here. At here. Here. Your means here. Yeah. That means the fault is here. So your eye need to look inside here. So what? So how are you going to find a Tevenian impedance? So you need to short here and short here, right? So I need to do here. So all here series, then parallel with this one. Same as to here, series parallel to this one. Same to here. Here you actually open circle is only this side. Then you are going to get the x0 value, the zero sequence value we call z0, z1 value, and z2 value. Can you understand this? From this diagram, you know, so from this diagram, zero sequence diagram, then you will get x, so-called the z0, z0. Okay, then z1, then z2. So after you have these three values, then nothing really. This is altered three-phase to ground short circuit. It means it is a symmetrical fault because it is all shorted together. So symmetrical fault actually nothing. Just use IAIBIC to find only Ohm's law only. Okay. So then next we go to the unsymmetrical fault. So basically unsymmetrical fault you have three conditions: single line to ground, line to line, and double line to ground. So single line to ground will be this one line. The diagram that you need to memorize if it is a physical exam. Yes, it's like a reverse E. Very easy, right? And this is only a series circuit, right? It's actually a series circuit. So normally ZF value not given, that means you just short here. Okay. Then can you find I0, I1, and I2? Given VF. Z0, Z1, Z2, just now you found already, right? From from the question, you draw the impedance, you find the PU value, the new PU value, then draw the diagram out. After you draw a diagram out, your eye will look inside the fault location and then find the Tevenian impedance, so-called this positive sequence, so they give you Z1 value, then negative sequence will give you Z2 value, then zero sequence will give you Z0 value. So from this Z0, Z1, and Z2, now you substitute into here. Like that only. You substitute into here, then you can find I0, I1, I2, V0, V1, and V2. Should not be a problem because this is just a series circuits. I0 equals to I1 equals to I2. Okay. Then example, nothing lah. Or I0 equals I1, I2, I0 equals I1 equals I2. How to write? V divided by the total impedance only. Okay. And you want to find V0, V1, and V2, it's not a problem. Just use what is it? The Ohm's law only. Okay. Then V0, V1, and V2, you want to get VA, VB, and VC. Still remember this formula? Convert. This is the place that I said. I won't set the questions for symmetrical, the sequence network chapter, okay? But I will combine it with the unsymmetrical fault. So you do this, then you convert. So unsymmetrical fault chapter, normally a lot of marks. Last time during COVID online exam, I give 40 marks. Now I separate into two questions. Also roughly 40 marks as well. Okay. Then next will be line to line fault. Line to line means two of the line short together. Then we call line to line fault. And this is a diagram that you need to memorize if it is a face-to-face exam. ZF normally short. Okay. Then Z0 and I0 is separate diagram that actually equals to 0 only. Okay. So I1 is equal to negative I2. V1 is actually equal to V2. So it's very easy, right? Can you find I1, I2, V1, and V2? I don't think you have any problem. If you have problem, that means you should fail your circuit analysis. Okay. Then next will be actually you don't need to care about this. Don't need to care about this. Okay, you have I0, I1, I2, then you just use a formula to convert to phase. okay, to convert to A, B, C. And don't care about the double right. Double right is sub-transient. Sub-transient means that you know what is a transient, right? So transient means you from on to off or off to on stage, right? Then you have transient, sudden spike. Okay. Then sub-transient means it's sudden spike, right? Then in front of the few maybe microsecond or millisecond, then we call sub-transient. But not really care. I not really need to care about this sub-transient fault. You just do as usual. Okay. Then double line to ground fault means you have two lines to ground, so we call double line to ground fault. Then this will be the diagram that you need to memorize. So basically, you just need to memorize 3 diagrams, yeah. And this one, normally the F will be short, okay. The no value given means it's a short. Then this two parallel, this one series, this one. So it's a little bit harder than just now. The two circles, because that 2 circle is just a series circle. So this one is parallel than series. Like that only, it actually not really have a big problem to you. Okay, so I1 here, I2 and I0, so you can use what current dividers rule to find I0 and I2. V0 and V2 should be the same if this is a short. So parallel, that means voltage V2 and V0 should be the same. V1 also same. Okay, so that's why they didn't ask you to find the voltage value. Too easy. Okay, so you have I1, I0, I2 by using this one, current dividers rule, I think. Then use a formula to convert to IB, IA, IB, IC, sequence to phase. This is a briefing for unsymmetrical fault chapter. Do you have anything that you would like to ask? Hello? Any problem? So far, so good? So basically, it's 3 circuits that you have to memorize. And you only have single line to ground, line to line, or double line to ground fault. I will only ask in between these 3, any one of it. Okay, good. So you can try to do the tutorial question. And I will discuss with you all again. If you don't have any questions, then I would like to end the class now. Can I? Can I? Don't forget to complete your lab assignment. And yeah, I leave a message to some of you, right? To ask you all to resubmit the report for the case study. Some of you submit only the turn-in without the complete report. Some of you submit the other one. So please do it. And another thing is, submitted already. Okay. Song Jian, then Xiu Qing Yang, how already? He is not in the class. I haven't checked it. Ying Xuan, let me check and again. And anything will leave your private message. Okay. Song Jian, how about your friend? Oh, he said he may be a deeper. Oh, okay. Okay lah. If no problem, then deeper. I don't know. So because he hasn't really submitted the case study assignment. Okay, please tell him to make a decision earlier lah. If not, then yeah, all the assignment will get stuck, and then I don't know what should I do. Okay, if he want to defer, then ask him to decide earlier and inform office. Thank you. Okay, if no problem, then see you all next week. Bye.